Okay, today we're looking at word problems. We've already looked at word problems, so we did that in our algebra unit. So what we're going to do now is we're going to go from our word problems into an equation. Then once we have an equation, we're going to graph that equation. That's going to allow us to answer questions by using the graph. And that's our whole goal, is to see a picture of the equation, which is the graphed line. So recall that the number that stays the same is called the constant. We want to be able to identify the constant. We also want to identify the rate of change. That one's really important. It's the amount that something changes by. For example, if you go to the store and buy 5-cent candies, if you change the number of candies, say you buy, 10 candies, how much is it going to cost you? Well, times it by 5 cents, that equals 50 cents. You go into that store and now you buy, let's say only 5 candies. How much is that going to cost you? Well, 5 cents times 5, that'll cost you 25 cents. Okay. What if you go in the store and you buy 20 candies? So 20 candies times the rate of change of 5 cents is going to be 5 times 2 is 10 plus the other 0, 100 cents. And most of you are thinking, how much is that? Exactly, $1. Okay, so you got to watch for your units as well. Now, what if you did use a different rate of change? For example, instead of buying 5 cents candies, you went and spent the big money, and each candy was 25 cents. Let's say you bought 3 of those. So you take your rate of change, multiply it by 3, and that would be 75 cents that you owed the store clerk at 7-Eleven. So what we're doing is taking our rate of change, multiplying it by x, and we're adding the constant. You want to make sure for each problem you can clearly identify which one's your constant, which one's your rate of change. So let's have a look at the first example. Okay. A machine salesperson earns a base salary of $40,000. Plus a commission of $300. So what's the important stuff that you should underline? You should underline the base salary of $40,000 plus the commission of $300 for every machine, or each machine, or per machine that he sells. Those words are the indication, right? Every, each, or per, or a machine. That's keywords to indicate the rate of change. The base salary, that's indicating that the $40,000 is always given and more is added on. So that's going to be your constant. Okay, so to write the equation then, we're going to take our rate of change, multiply it by x, and then add the constant. So y will equal $300, or 300, we don't need our units, times x plus the constant of $40,000. Okay, here we have our rate of change, 300. Here we have our constant, 40,000. So what if he doesn't sell any machines?
Could Mr. Smith please contact the office? Mr. Smith will call the office.
If he doesn't sell any machines, in other words, x is 0, how much will he get paid? Well, no matter what, he gets paid $40,000. What would be some other good numbers to choose for x? Well, x is 1. He sells 1 machine. How much will he get paid then? Well, we get y equals 300 times 1 plus 40,000. Okay. So y equals 300 plus 40,000. Easy math. Y equals 40,300. What if he only sells 2 machines? how much would he make? 40,600. Okay, he adds another 300. You can see from the pattern, each time, what are we increasing by? We're increasing by the rate of change, which is 300. So remember we talked about looking at patterns. That's one pattern. Why should you not choose X being negative numbers? Why didn't I do that? Why didn't I include -2 and -1? Well, the reason why you wouldn't do that is because you can't sell negative machines. What would that look at like? If the business sold -1 and -2 machines, is that like a refund? What is that? It doesn't make sense. They wouldn't pay them for a refund. Okay, so we're just going to start at 0 and go up. You're going to have to choose smart values. Now, speaking of choosing smart values, going up by ones seems a little ridiculous. What we could do is go up by tens. So 0 would be 40,000. 10 would be what? 43,000. And what about 20? That would be 46,000. Now you could check that by y equals 300x plus 40,000. Okay, so y equals 300 times 10 plus 40,000. So y equals 3,000 plus 40,000. So y equals 43,000. Okay. Now, got to graph it. Okay, for graphing this, we're going to cheat a little bit. This is not a good grid to use. So what we're going to do is kind of make our own grid and improvise a little bit. These are going to be more science type graphs. We're dealing mostly with the first quadrant because they're actual objects that we're graphing. So here's X, there's 0, he sells 1 machine, sells 2 machines, sells 3 machines. Let's go here, 10,000, 20,000, 30,000, 40,000, $50,000. So if he sells 0, he's going to make $40,000. If he sells, let's graph the second one. Oops, I screwed that up. Let's go here, 10, 20, 30, there we go. If he sells 10 machines, it's 43,000. So that's approximately here. If he sells 46, so 20 machines, he's at 46. So that's approximately there. And so now we have a line. This line is going to be a little bit different. We do not go into the negatives. So this line is going to start at 40,000. That's for sure. That's exact. And it's going to go off in that direction. So now we can use that to predict his salary if he sells 30. So if he looks at this real quickly, he could calculate it using the formula. Okay. However, he could also just go up to the line and go over, and he'll be making about $51,000. Now, the formula would be more accurate, and we could see that's not going to be quite that. Okay, it'd be at 49,000. But the graph gives a very quick, easy picture. Okay, and this is called extrapolating or extrapolate because they are extra points. Okay. So a couple other things we should look at. This would be the number of machines. Number of machines sold, because you want to have a title. This would be the
Visit
his.
Scott, please call local 4131.
This here would be his salary in thousands. So 10,000, 20,000. The units is dollars. Units go in brackets. Number of machines don't have units because it's just a number reflecting the number of machines sold. Otherwise, you should always put your units, units in brackets. Nice little title for a graph. This would be the salary, the salesman's salary. Saleman's, sorry.
Taylor, please contact the office. Miss Taylor, please contact the office.
Salesman's salary or salesperson. And there you go. So nice little picture of how much he's going to make. Any questions? Okay, continuing on. Example number 2. Mr. T's on a diet. He currently weighs 260. He loses 4 pounds a month. So 260, that is his constant. Loses 4 pounds a month. A, that's indicating the rate of change. So please underline this and make a note so you can start recognizing this in your word problems. Don't just stare at the screen, actually underline it. Highlight A, that's a very key word. Okay. So write the equation, y equals the rate of change, okay, times x plus the constant. So the y equals, when you lose, what kind of number is that going to be? It's going to be -4. Okay, so you're losing -4 times x plus 260. Okay. So, creating a table of values. What numbers make sense for m? Does it make sense to start at -2 and work your way down? Absolutely not. We're not concerned about the negatives. We're going to be concerned in time 0, time 1, time 2 for months. So now we can find out the weight. Now instead of y and x, we should put the weight equals -4m plus 260. Okay. So his new weight will be -4 times 0 plus 260. Notice it says starting weight. It's the constant. That's really important to see that at m equals 0, w is 260. Okay, that's really important to notice. Good. Next one then. W equals -4 times 1 plus 260. So W is 256. Then you can also just apply your rate of change, right? The -4. So if I minus 4, what should I get? 252. So W here for this one, W equals -4 times 2 months plus 260. W equals -8 plus 260. And that's right, 252. Okay. So again, I wouldn't do this type of graph. Let's do a science type graph. So we're going to just kind of estimate a little more. Oops. Lucky for me, I've got this. So what we're going to do is we're just going to put that on there. So we're going to pretend that this is just one big grid. Okay. That's not going to work very well. Let's put it right here because I wrote there. Good. Okay, so this would be the number of months. 0, 1, 2, 3, and we're at starting at 260, so let's go 50 pounds, 100 pounds, 150, 200, 250, 300. So starting weight of 260 means he started right about here. Okay, that's somewhat accurate enough. Then after 1 month, fell just a tiny bit. After 2 months, fell just a tiny bit more. Oops. Good. And so what kind of error we're going to look at? We're going to look at one that starts at 260 and continues on down. So now Mr. T can look at his picture. If he wants to get back in the game, say, how long is it going to take me to get down to 240 pounds, a bit closer to his fighting weight? So we can then go over and down and say, it'll take him about 4 months or so. So obviously our graph's not very accurate. Okay, 240, and that'll probably take him about 4 months, but using the equation is more accurate. Okay. So, how many months until he reaches goal weight of 220? We can use the graph, but it's more accurate if you use the equation. Okay. If I give you the graph, then I'd use it, because we can get computers to do that much more accurately, but you need to understand the concepts so you know if the computer is doing it properly. So the equation is W equals negative 4m plus 260. Now the weight, or W, is 220. Negative 4m plus 260. You can work backwards. How do you move the plus 260? Or how do you unwrap it? Minus 260. Oops. So negative 40 equals negative 4m. Divide by negative 4 to get rid of it. And so you're going to get 10 equals m. So it'll take him about 10 months to get down to 220. Any questions? Okay, our last word problem is a little bit different format. So here we have both variables being affected by a rate of change. So the school play children's tickets cost $3 each. There's that word each. Adults cost $7 each. There's that word each. So we could use X and Y, but what else could we use to reflect the difference between children's tickets and adult tickets? I underlined those letters for a reason. It would be C and A. That would be very, very reflective of children's and adult tickets. So total is $210. So a child's ticket is $3 per ticket, so 3 times C, plus $7 for the adult tickets, or 7 times A. If you multiply them and add them up, the total revenue, or money earned, is $210. Okay. So we could use X and Y, or for children's tickets we could use C and we could use A. Now let's just go and convert that. 3x plus 7y equals 210. The only reason why we're doing that will be a little bit easier when we graph it. Okay. So if 24 adult tickets were sold, how many children's tickets? We can use the equation. So 24, 3x plus 7 times 24 equals 210. So we can substitute in for y the value for 24. Okay. So we get 3x. Now we solve for x. That's what we're asking for. Solve for x. So 3x. Go ahead and do that yourselves. Okay, so 7 times 24 is 168. Plus 168, then we have to subtract. So we get 42, divide that by 3, Y, I'm using my calculator, but I am. X is 14. Okay, so there's 14 child tickets sold. Hold on for a sec. Let's go back up. I didn't finish this graph off. This would be his weight. The units would be pounds, LBS is the short abbreviation. And this would be Mr. T's weight loss. Okay, there's your title. So title, units, don't need units, but you have to label it. Okay, so label with units if appropriate, months you don't need. Sorry about that. Going back, let's do a little table of values for children's tickets. So, complete a table of values and graph the relation. We just made up one here. We can do 24. Actually, you know what we need to do? 3x plus 7y equals 210. What we should do here is change this into y equals. Please take your time. Change that into y equals. So, move the 3x over by minusing 3x. We get 7y equals negative 3x. Always write that first. Plus 210. Then divide by 7. So left side is divided by 7. The entire right side is divided by 7. So we get y equals negative 3 divided by 7x plus 30. Okay, so 210 divided by 7. I can write that there if you want. 210 divided by 7. But the answer is 30. So, when x is 0, what's y? Well, y is 30. Okay, when x, what are some other numbers? Ooh, hold up there. Stand by one. Okay, some other good numbers to use would be 7 and 14, because they're multiples of 7, the denominator. So we can then substitute in and solve for some good y values. So y equals negative 3 over 7 times 7 plus 30. 7 divided by 7 is 1. So y equals negative 3 plus 30. Y equals 27. Okay. Then we can get y equals negative 3 over 7. Whoops. Times 14 plus 30 and divide 14 divided by 7. Y is 2, so negative 6 plus 30, 24. What's the pattern? We're going down by 3's. Okay, so to graph it, we're going to have to do another graph by ourselves over here. And we're going to have to improvise. So x is 0, y is 30. Let's go 10, 20, 30. And here we gotta go 14. So let's go 5, 10, 15. Okay. And so 0, we get 30. And at 7, we get 27. So we'll go here. And at 14, we get 24. So about there. Now with this graph, eventually we're going to get to 0. Okay. Eventually we will get to 0. I just haven't made the graph big enough. Okay. Good. This will be the number of child tickets. This here will be the number of adult tickets. And a title for the top could be revenue from the play, is it? What is it? From the play. Okay. There we go. Any questions?